Hello everybody and welcome. My name is Mr. Cantor and this is Modeling with Mr. Cantor. Now today we're going to be looking at Explore Part B. What I want you to do is to please read this story, look at the dot plots provided to us, and then think about them a little bit. So please pause this video, have a chance to digest this information, and then we will look at it together. Alright, welcome back. So let's read and see what we have here. It says, here are dot plots showing how long Diego's trips to school took in minutes, which you studied earlier, and how long Andre's trips to school took in minutes. The dot plots include the means for each data set marked by triangles. So we can see this first dot plot is for Diego's travel time in minutes, and we can see there's a triangle here to represent where is the mean or the average of his time, which is 11. Now we have Andre's travel time in minutes, and we can see that his triangle is on top of the 14, which simply means the mean of his data is 14, or the average of his data is 14. So let's look at part A. Which of these two data sets has a larger mean? In this context, what does a larger mean tell us? So please pause this video, think about this one for yourself, and then let me know. What do you think the answer is? All right, welcome back. If you said that Andre's dot plot has a larger mean, and that in this context, this results in Andre having to travel longer on average than Diego, this could also mean that he lives further away from school. If this is what you said, then you are correct. Now, there's a lot of different ways that we can analyze this information, but we can see that this is definitely one of the possible reasons for why Andre has a larger mean than Diego. With that said, let's move on to part B. Please pause this video, read part B to yourself, and then we will read it together. All right, welcome back. Part B reads, which of the two data sets has a larger sum of distances to the left and right of the mean? What do these sums tell us about the variation in Diego's and Andre's travel times? Okay, so with that said, what I want you to do is to please pause this video, look at the data provided to you for Diego and how long it takes him to travel in minutes. Look at his data. I want you to find the distance between all the data points for Diego and his mean. Find that distance. Then what you're going to do is you're going to identify whether the data is to the left of 11 on the number line or to the right of 11 on the number line. Once you do that, I want you to take all of the values that you got for the left, find their sum, and then I want you to find all the values to the right of 11 and find their sum. So please pause this video, and then we're going to talk about this one together. All right, welcome back. If you noticed that for Diego, on the right side of 11, we have 12, 13, and 14. We need to subtract 11 from those values to find what is the distance of all the numbers to the right of 11. Then you would have done 12 minus 11, which would give you 1. You would do 13 minus 11, which gives you 2. And you would do 14 minus 11, which gives you 3. Then, for the left side, you would have noticed that 7 and 9 are both to the left of 11 on the number line. So therefore, we need to do 11 minus 7, which is 4. And then we need to do 11 minus 9, which is 2. So now we have officially found all our distances, the ones that are to the right of 11 and the ones that are to the left of 11. So we can see that the left total is 4 plus 2, which is 6. And the right total is 1 plus 2 plus 3, which is also 6. So we can see that the left and right side are equal because we are using the number 11 and tracking its distance from all the data that we have here. So the left and right should be equal because that is what the mean represents in your data set. It represents the center or the balancing point of your data. So with that said, in order for us to address this question, we need to figure out what are Andre's travel times. So please pause this video, take a look at what we did for Diego, and then I want you to replicate this for Andre. Okay, so now that we've completed everything for Diego, we're going to do the exact same thing for Andre. So the first thing we're going to do is look at what numbers are to the right of 14, find their distance from 14. Then we're going to look at the numbers to the left of 14 and find what is their distance from 14. So let's start with that. So we can see that the numbers on the right is 16 and 17. So we're going to do 16 minus 14, which gives us 2. And then we're going to do 17 minus 14, which gives us 3. So since 16 and 17 are both to the right of 14 on the number line, once we subtract, these are our distances on the right side. Next, let's look at the numbers on the left side. We have 12 and we have 13. But notice how there are 2 dots for the 12, which means we have to count 12 twice, or find the distance from 12 to 14 twice. So essentially, we need to do 14 minus 12, which is 2. That's for the first dot. Then we need to do 14 minus 12, which is 2 again, because there are 2 dots. And then finally, we need to do 14 minus 13, because there's only 1 dot on top of the 13. And that gives us 1. So our values from the right is 2 and 3. So when we add 2 plus 3, we get 5. And when we look at the values on the left, which is 2, 2, and 1, we will also get 5. So essentially, we know that 11 is the mean because the left and right side for Diego are both 6. And we can see that 14 is the mean because the left and right side have a value of 5, which means that 14 is the balancing point for Andre and 11 is the balancing point for Diego. All right, so with that said, let's read part B and figure out how to answer it. Part B says, which of the 2 data sets has larger sums of distances to the left and the right of the mean? What do these sums tell us about the variation in Diego's and Andre's travel times? So please pause this video and let me know. Now that we've completed all this work, what do you think? All right, welcome back. So if you said that Diego has larger sums of distances to the left and right of the mean, that is correct. And this basically means that his trips to school vary in length more greatly than Andre. Maybe he walks faster some days. So even though Andre's sums of distances on the left and right were both 5, and Diego's sums of distances to left and right were 6, that difference between the 2 of them is very small. However, we can see that Diego does have larger sums of distances to the left and right. So that can mean many things. Maybe he lives closer or he just walks faster. These are some things that we can think about. All right, my name is Mr. Cantor. Thank you so much for watching this video, and I will see you in the next one. Take care for now.